1.4, we're going to talk about the Pythagorean theorem, and I love the Pythagorean theorem. You're going to use this a lot, especially when you are with Mr. Schwab in geometry your junior year. This is going to come up all the time, so you're getting a little preview of what it is, and you're going to use the same formula over and over again. And I have a feeling a lot of you have heard this formula before, you just didn't know what it is. So we're going to use the Pythagorean theorem to find the length of a side of a right triangle. So this is a right triangle. We've got this right angle right here. And you can use this formula called the Pythagorean theorem to find any side length of a right triangle, which is pretty cool. So the whole formula that you're going to use and keep coming back to is a squared plus b squared is always equal to c squared. Okay? So what the heck do A, B, and C stand for? Well, A and B both stand for the legs of a triangle. Did you know they had legs? Did you know they could just get up and walk right off your paper? Those are the legs of your right triangle. So this right here, this side right here, and this side right here are your legs. And it doesn't matter which one is which. You could put A here and B here, or you could put A here and B here. It does not matter. I always like to make A the shorter looking one, and then this would be B. But again, you can switch those around. A and B don't really matter. The one that makes a huge difference is C, and C is the hypotenuse. Oops. Of your right triangle. It always reminds me of hippopotamus. So hippopotamuses are large, so the hypotenuse of a right triangle is always the longest side. So sometimes it's hard to tell which one's the longest just by looking at it. So the trick is the hypotenuse, or the C side, is always right across from the right angle. That's how you figure out what the C is. And I always say that you always look for C first, and then you can decide where A and B go. So the C side, or the hypotenuse, is always the longest side, and it's always across from the right angle. Okay? So when you label your triangles, always label C first. All right, I'm going to have you guys skip this little directions here for now. And we'll come back to those. That was awful. I don't even know what that is. So we're going to come back to those later. So let's just kind of jump into some examples. I'm going to write down my formula, so I always remember it. So remember, A squared plus B squared equals C squared. Let's try this first one. You're going to plug your information in to your formula to figure out one of the sides. So the side that we're missing here is C. So we're missing the hypotenuse. We know that this side should be the longest side when we figure it out. So we're going to plug in 3 for A and 4 for B and see what we get. So we're going to have 3 squared plus B is 4, so 4 squared should equal C squared. So I'm going to figure, it's going to simplify this side. C is all by itself, so 3 squared is 9, plus 4 squared is 16. And I still don't know what C squared is, so I'm going to write that here. And then I'm going to keep simplifying. So 9 plus 16 gives me 25. I'm going to keep bringing this down. And a lot of people, the most common mistake is that you stop right here and you say, oh, I'm done. C is all by itself. But we know from solving these quadratic equations that we are not done until this exponent is gone. So how do you get rid of a square? The opposite of squaring something is square root. Okay? So you're going to find the square root of both sides. So in this case, C is equal to square root of 5. It's a perfect square. So C is equal to 5. Okay? This part right here, from here to here, we've done this. You guys know how to solve quadratic equations. The new part is just plugging your correct information into your formula. And notice how I kept organized with each part. Okay, so keep that in mind. I'm going to skip this one for now, and we're going to try number 4. I'm going to skip 2 and 3 for now. So we're going to try example number 4, and we'll come back to those. So this time I'm given a visual. It doesn't tell me what A, B, or C is. So what I would do is circle your right angle, And I remember across from that right angle is always the hypotenuse, which is C. So I'm going to write C right here. 17 is C. And remember, A and B do not matter. Okay, you can interchange those, it doesn't matter. I'm going to just say that this side is A and this side is going to be B. Okay, you could flip-flop those, but that's what I'm going with right now. So now I have information like I had up here. So I'm going to plug this into my formula. So I'm going to have 8 squared, because that's my A, plus, I don't know the B, so I'm going to write B squared equals C is 17. Okay, so I have my information in my formula. Now it's time to simplify what I can. All right, so 8 squared is 64. I'm going to bring everything else down. And 17 squared is going to give me 289. Okay, so now, my B is on this side. I need to get this by itself because that's what I'm solving for. So I'm going to subtract 64 on both sides to get B by itself. So I'm left with B squared equals 225. I'm not done, remember? I'm not done until this exponent is gone and the B is completely by itself. So the opposite of squaring something is finding the square root. Okay, so these cancel out. B is equal to square root of 225, you should know, is 15. Alrighty? So that's how you use the Pythagorean theorem to help you find the side of a right triangle. So that would mean that this side right here is 15 feet, inches, whatever, long. Okay? All right. I would like you guys to try number 3 first. Okay? You must solve number 3. And then if you're feeling gutsy and you're feeling good, go ahead and try example 2 as well. All right? And check your answers. All right? Good luck.